Hello everyone. In this program, we'll try to demonstrate the need of synchronization. Okay, so basically in this program, we have an object of a shared resource class. Okay, so shared resource class object. Okay, that object is called S. The class name is shared resource. It has a data member called count, which is private, and it has a public method get count to get its value, and you have a public method called increment to increment its value in a loop, basically. Okay. Now you have two threads. You have two threads, thread 1 and thread 2. Now, how exactly do they share this particular object or this particular resources? Both of them contain a reference. Both of them contain a data member, which is a reference to shared resource, and in both the threads that particular reference variable contains the address of the same object s. Okay, and their run method their run method calls the increment method from s. Okay, so now what happens is both the threads are trying to increment the value of count for 10 times, for 10 iterations. Okay. Now what is happening here is thread 1 will read a certain value of count and try to increment it by 1. So firstly it reads the value, as you can see over. So here it reads the value, that is, and then it increments it. So let's say in the beginning, either one of the threads will randomly get the access. In the previous videos, you have seen how concurrency works. So you don't know whichever thread will get a chance to get spawned and start running first. Let's say thread 1 gets the chance first. So thread 1 will read the value of count as 0, increment it to 1. Okay. So let's say if I just scroll this up, or I'll just write it over here. So thread 1. Okay. So let's say this is the count variable. Thread 1 reads the value 0, increments it to 1, and it writes. Thread 1 writes 1. Now, before thread 1 writes 1, what if? So, let's say this is thread 1. Okay. Before thread 1 could write 1, what if thread 2 reads the value of count, that is 0, and also increments it and also writes 1. Okay. So, now thread 0 writes 1. Ideally, what should have happened? Because these are two separate operations, these are two separate iterations. Thread 2 should have read 1. It should have waited till thread 1 finishes writing the value, and then it should have read that value which thread 1 wrote, and then it should have incremented it to 2. But despite having two iterations, two iterations, but the increment, but only one increment. Okay, but only one increment. There is only one increment. Okay. Similarly, let's take any other random iteration. Let's say the current value of count is 10. So let's say thread 2 reads the value 10. Okay. And before it can increment and write 11, thread 1 also reads the value 10 and also writes the same value 11. So again, we have the same problem. There are two iterations, but only one increment. Okay. So this will become clearer when you see the output of this program. Now for 10 iterations, because our processors are very fast. Now what is happening here is, so I'll just go through the rest of the program as well, just as I told you over here. In main method, we create a shared resource object called S, and we pass the address of that object to both the threads. So both the threads are pointing towards the same object, and both of them are calling the increment method of the same object when we call the start method, when we start the threads. Now in the run method is nothing but a call to the increment. And in the increment method, what we are doing is we are first running the loop, and then finally it prints the message. That is what is the name of the thread and what is the final count read by that thread. So in this case, thread 0, the final count that it read was 10. And basically it means that when thread 0 got control, it could quickly execute the 10 iterations, and the final value of count was 10. So 0 to 9, and in fact 10, the last iteration, and thread 1 read the value 10, and it increments from 10 to 20. Okay, and why does it print in this order, like thread 1 first and thread 0 later? It is a result of concurrence. Whichever gets the chance to print first will print it. Okay, now because it's a less number of iterations, once a thread gets a control, it can quickly execute 10 iterations. So there is no problem. In a fast processor like we have here, there is no problem. Okay, let's try 100 iterations. Still no problem. Let's try 1000 iterations. Still no problem. Let's go for 10,000 iterations. Huh. So here we have a problem. What should have been the result? So let's ignore whatever intermediate value one thread reads or other thread reads. But the final value should have been 20,000 over here.